Have you ever looked up at the night sky and felt a sense of wonder, a sense of peace? What if I told you that same sky holds a threat so immense, it could end life as we know it in a single, catastrophic moment? This isn't science fiction. This is our reality. Earth is floating in a cosmic shooting gallery, and we are the target. Imagine a doomsday asteroid hurtling towards Earth. What if we told you, by 2050, we could actually stop it? Get ready to explore the groundbreaking technologies and audacious plans that could turn science fiction into our planet's ultimate defense. Let's start with a history lesson written in stone and stardust. 66 million years ago, a colossal asteroid, estimated to be about 10 kilometers wide, slammed into what is now the Yucatan Peninsula in Mexico. The impact was equivalent to billions of atomic bombs, triggering a global winter that wiped out the dinosaurs and over 75% of all species on Earth. It's a chilling reminder that our planet has been hit before, and it will be hit again. The evidence isn't just in the ancient past. In 1908, a smaller object exploded over a remote part of Siberia in an event known as the Tunguska event. It flattened over 2,000 square kilometers of forest, an area larger than London. Had it struck a major city, the casualties would have been unthinkable. More recently, in 2013, a meteor exploded over Chelyabinsk, Russia. This one was only about 20 meters wide, but the shockwave shattered windows across the city, injuring over 1,500 people. And the scary part, we never saw it coming. These events aren't just random cosmic bad luck. Our planet's massive gravitational pull acts like a cosmic vacuum cleaner, pulling in nearby rocks and debris. We are constantly crossing paths with countless asteroids and comets that share our solar neighborhood. So, the question isn't asterisk, if asterisk a major impact will happen again, but asterisk when asterisk. Right now, our first line of defense is detection. Agencies like NASA and the European Space Agency have programs dedicated to scanning the skies for near-Earth objects, or NEOs. Projects like the Catalina Sky Survey and Pan-STARRS have discovered thousands of these objects. They've catalogued over 90% of the planet-killer-sized asteroids, the ones larger than a kilometer. The good news is, none of them pose a threat for the foreseeable future. But here's the unsettling truth. We're still mostly blind to the smaller, city-killer-sized asteroids, like the one that caused the Tunguska event. There are likely millions of these objects out there, and we've only found a tiny fraction of them. They are smaller, darker, and much harder to spot until they're dangerously close. We need a more advanced warning system. This is where projects like NASA's NEO Surveyor mission come in. Set to launch in the coming years, this space-based infrared telescope will be a game-changer. By operating in space, it won't be hindered by Earth's atmosphere or the day-night cycle. It will be able to detect these elusive, darker asteroids, giving us years, or even decades, of warning. And with that warning, we can actually do something. So, how do you stop an asteroid? The Hollywood solution is usually a brave team of astronauts, a big drill, and a nuclear bomb. While dramatic, the reality is a little more nuanced, and frankly, even more brilliant. Our first proven method is the kinetic impactor. Think of it as cosmic billiards. You don't need to destroy the asteroid, you just need to nudge it. By hitting it with a high-speed spacecraft, you can alter its velocity by a tiny, tiny amount. But over the vast distances of space, that tiny nudge, applied years in advance, is enough to make the asteroid miss Earth entirely, and we know this works. In 2022, NASA's Double Asteroid Redirection Test, or DART mission, was a spectacular success. The DART spacecraft intentionally crashed into a small asteroid moonlet named Dimorphos, which was orbiting a larger asteroid, Didymos, millions of miles from Earth. It wasn't a threat to us, making it the perfect test subject. The goal was to see if the impact could change Dimorphos's orbit around Didymos. The results were better than anyone hoped. The impact shortened the moonlet's orbit by a full 33 minutes, far exceeding the mission's minimum success benchmark of just over a minute. The DART mission proved, for the first time in history, that humanity has the capability to change the motion of a celestial body. We are no longer passive spectators in the cosmic arena, we are now active defenders of our planet. But what if a kinetic impactor isn't enough? What if the asteroid is too big, or we don't have enough warning time? We need more tools in our planetary defense toolbox. Enter the gravity tractor. This is a concept straight out of elegant physics. You don't even have to touch the asteroid. Instead, you would fly a heavy, robotic spacecraft alongside it for an extended period, maybe months or years. The spacecraft's tiny gravitational pull, though minuscule, would slowly and precisely tow the asteroid onto a new, safer trajectory. It's a gentle, controlled approach, perfect for situations where you need to be incredibly precise to avoid accidentally sending it on a collision course with another celestial body, or breaking it into smaller, equally dangerous pieces. The gravity tractor is ideal for when we have decades of notice. It's a slow and steadied Windsor's kind of solution, but sometimes we might need a bigger push. This leads us to more advanced, and admittedly more controversial options. The nuclear option, while a movie staple, is a last resort. Detonating a nuclear device on or near an asteroid is incredibly risky. It could fracture the asteroid into multiple large chunks, creating a shotgun blast of impacts instead of just one. A much safer approach is a standoff detonation. By exploding the device at a distance, the X-rays and radiation from the blast would vaporize one side of the asteroid's surface. This creates a powerful, rocket-like thrust that pushes the asteroid off course. It's a more controlled use of immense power. Then there are even more futuristic ideas, like using high-powered lasers. A powerful laser beam, either from a spacecraft or even based on Earth, could be focused on a spot on the asteroid. This would heat the surface material, causing it to vaporize and create a jet of gas, effectively creating a small, continuous thrust. Over time, this gentle but persistent push could steer the asteroid away. It's like a tiny, focused rocket engine powered by light. The beauty of all these methods is that they are not mutually exclusive. The future of planetary defense will likely involve a combination of these technologies. Imagine a coordinated response by 2050. A new, threatening asteroid is detected by the NEO Surveyor. We have 20 years of warning. First, we send a scout mission to analyze its size, shape, rotation, and composition. Is it a solid rock, or a loose pile of rubble held together by gravity? Based on that data, we decide on a strategy. Maybe we start with a gravity tractor for a few years to begin the nudging process precisely. Then, as it gets closer, we send in a kinetic impactor for a more substantial push. And we'd have other impactors, and perhaps even a standoff nuclear option on standby, just in case. This layered, multifaceted defense system is our best bet for ensuring Earth's safety. This isn't just about technology, it's about global collaboration. An asteroid threat is a global threat. It doesn't care about borders or politics. The response must be international. Organizations like the United Nations Office for Outer Space Affairs are already working to create frameworks for a coordinated global response. The DART mission itself was a massive collaboration, with observatories all over the world, both professional and amateur, tracking the outcome. This is a challenge that can, and should, unite humanity. By 2050, we can realistically have a robust planetary defense system in place. We will have a comprehensive map of our cosmic neighborhood, with advanced telescopes spotting threats decades in advance. We will have a fleet of ready-to-launch spacecraft, equipped with kinetic impactors, gravity tractors, and other advanced deflection technologies. We will have the international agreements and protocols to act decisively and collectively. We are living in an extraordinary time. For the first time in the 4.5 billion-year history of our planet, one of its species has developed the intelligence and the technology to prevent a major extinction-level event. The dinosaurs looked up and saw their doom. We can look up, see a threat, and have the power to stop it. The work being done today in labs, observatories, and space agencies around the world is for our children, and our children's children. It's the ultimate insurance policy for humanity. By 2050, we won't just be inhabitants of Earth, we will be its guardians. The future isn't just something that happens to us. It's something we build, and it's something we must protect. Thank you so much for joining me on this journey into our planet's future defense. If you found this fascinating, make sure to hit that like button, subscribe, and ring the bell so you don't miss our next exploration into the cosmos. Let me know in the comments which deflection method you think is the most promising. Until next time, keep looking up.